So now what we're going to do over here, as you can see on your screen, is let me just put our data here that we're dealing with. So we have this. Let me print the head of this so that we can actually see the data that we are dealing with over here. Okay, so this is the head. This is the head of the first 5 rows of the training data that we have, right? So let's see the same thing for the testing data, the first 5 rows of the testing data. So I'm going to use that, and then I'll use head over here. All right. So now this is the 2 data sets that we have. That's the training, and then the testing. Okay. So what I'm going to do over here is to divide my data set into dependent, right? Into dependent variable, right? You can also call it target variable, right? And then independent variables, right? Independent variables. So that's what I'm going to do. So we know that this is our target. The action is our target, and it's present in the train data, right? The train data frame, right? So I'm just selecting that, and then I'll store it in Y, right? I'll select that, and then I'll store it in Y. And then for the rest of it, right? The rest of it, apart from the action, right? So that's what I'm dropping the action, and then specifying that it is present in the column by using axis equals 1. If you use axis equals 0, you are saying that it's in the row, but in this case, or in the index, right? But in this case, it's in the column. So I'm specifying that whatever I want to drop is in the column, and I'm just dropping the action so that whatever is left will be stored in X, right? And then let me just go a little bit up so that you can actually see what I'm doing. Okay, so if you take this, right, let me zoom a little bit out. Okay, what I'm doing to get my Y, right? So this is actually my Y, right? And the rest of this, right? The rest of that, all this, right, becomes my X. Okay, so I just select, pick this. Which is train df, right? Now in train df, I just select only the action, right? I just select action. So the rest of it, so in order to get the rest of it, I can select each of them one by one. But in order to get just get everything as easy as possible, so my X, I just drop only this. If I drop this one, right? If I drop this one, then whatever is left is this. Then I store whatever is left over there, right? I just drop only the action. Then whatever is left will be stored in X. That's what is actually happening down here, right? That's what I'm actually doing. So I'll just drop the action, and then I'll pick the action for X. And then if we go to the test, right? If we go to the test df, I'm dropping the ID because we are not going to use the ID. ID is just an index that they were giving, just like pandas will give us this 0, 1, 2, 3. So this 1, 2, as they were collecting the data, they gave it ID as 1, 2, 3, 4, 5, all the way to the last that we have in our data set. Okay, so after we have divided our data set into training, into dependent and independent variable, what I'm going to do is to use this train test split, right? So as you can see over here, let me do this a little bit. Yeah, what I'm going to use is this train test split to split my data, right? So I'm going to split the Y and then the X, right? And don't forget, we have a test data already, right? We're having 2 data set tests, and then we also have train, right? We have train, right? So now in train, we have divided the train into dependent and independent, where I store one in X and I store the target in Y, right? And then we have our test, right, where I have stored the test in what is called S_test, right? So as you can find this one here, and then this X, as you can find it over here, and then this Y, as you can find it over here. So this X is what I'm putting over here, okay, and this Y is what I'm putting over here. This test will be reserved for testing our model. After we have built our model, we use this to actually test it. Okay, now as we are building our model, we actually need to be checking over and over again to see that we are on the right path, whether we are getting a good accuracy or not. So for that, we are going to also have something called the validation data. Okay, so now if we divide our x, right, we store some, we use some to train our model, then we use some to validate it. The same way, if we divide our y, we use some for training, we use some for validation. Okay, then I'll store each of them. So the one, I mean, if I divide the x, the ones that I will use for training, I'll store it in x underscore train. The one that I will use for validation, I'll store it in what is called s underscore validation. The same thing I will do for y. The one that I will use for training, I will store it in y train. The one that I will use for testing, I mean for validation, I will store it in y valid. Okay. Now I'm using 0.25 here, which is the test size. Test size is nothing but how you want to divide your data set, right? So you need to divide your data set into training, in this case into training, and then validation, right? Into training and validation, right? So in the previous project, we're dividing our data set into training, right? Let me just change this one. We're dividing our data set into training, and and also testing, right? Into training and testing. Now what we are doing over here is actually dividing our data set into training and then validation, right? Into training and then validation, training and then validation. Okay, so now what we are doing, this 0.25 is saying that I'm going to use 75% as against 25%, right? So let me do it this way. So 75% for training and then 25% for validation. Okay, so that's why it's giving me test, although it's test size and not train size, I mean validation size, but it's actually communicating the same concepts over here. Okay, so I will reserve 25% of my data for validating the model that I'll build, and then I'll use 75% of the data to build the model. Okay, that's what I'm going to do. Then after everything is done, then I'm going to use my test data, which I have stored over here, to actually test my model. Okay, so let's go a little bit down and see. Now, as I said, we're going to use the Cutboost classifier, because we actually have we have Cutboost classifier, and then we have the Cutboost regressor, right? Regressor. Okay, so if your problem is a classification problem, right? If it's a classification problem, then we use the Cutboost classifier. If your problem is a regression problem, right, that's if you are predicting a continuous variable, then we use Cutboost regressor, right? So if we're going to predict, say, the stock market price, or we're going to predict, say, GDP of a country, right, it could be maybe 0.9 to something like that, or maybe stock price, so something like that, for instance, could be maybe 24.6601, something like that. All right, so that becomes a regression problem. We're going to use Cutboost regressor, but in this case we have 0 and then 1. It's a classification problem. See that we predict 0 or we predict 1. Okay, so that's why we're using Cutboost classifier over here. All right, now moving on over here, what I'm going to do is when you take the Cutboost, let me change, I think I can use say hello here. Okay, now if we take the Cutboost classifier, right? If we take the Cutboost classifier, I think I don't like this. This is cool, right? If you take the Cutboost classifier over here, it has a lot of parameters. Let me just show you over here. If you go to the documentation, right? If you go to the documentation, you can see a lot of this is Cutboost regressor, right? You can see the various libraries that you can use over here. A lot of them, right? I mean the various parameters that you can use over here, right? So all these are hyperparameters that you can actually tune to get a better model. Okay, so you can see a lot of them here. What I'm using is just a very small one. All right, so I do not want to I just specify them, then I'll put them here. Now in order for me to be able to be keeping on changing these hyperparameters or manipulating them, I just store them in a variable called params, right? So that when I come here, I can put them back here, right, as hyperparameters. So I could have just deleted this and then write these parameters that I want over here, right? Write them inside here, right? But in order for me to later on be able to just manipulate this, I just put them in a different variable, right? So when I'm using this to start saying that since I'm not specific of which parameters that I'm going to use, I just use these ones over here, so that to take care of them over here. All right, so that I'll be able to have a flexibility of increasing and reducing it at any time that I want. Okay, now I'm using this time. I'll show you when we are seeing the results, right? I'll show you that now. This, don't forget, this is the algorithm, and then we initialize it and store it in a variable called cat model 1, right? Because I will do another one again, so I just store it in a variable called cat model 1. I just store it in any variable that I want, maybe just as simple as model, right? I could have just done that. Okay, it's just a variable name that you want. You can just manipulate it as you want. Okay, now after that, after initializing it, right now our algorithm is now initialized to this variable. So if I use this variable to actually fit on what? Fit on the training, right? Remember that I said that I'm going to use this training to train my model, right? To learn from my training data. Okay, I'm going to use this training data so that my algorithm will learn from it. Okay, so that's what I'm doing over here. Now my algorithm is going to learn, right? So if I do .fit, it means that learn from the X training and then the Y train, right? So learn from these data. Okay, that's what is actually happening over here. And then after I made it learn from it, I'm going to use the evaluation, right? I'm going to evaluate it on the S validation, and then the Y validation data. Okay, and then I'm using best model equals true. I've given why I'm doing that over here. So true if we don't want to save trees created after iteration with the best validation score, right? So the best validation score. Okay, so if we don't actually want to store what we did earlier on, then we use best model equals true, so that we can actually get it over here. So if you can see over here, you can see that we only have these ones. Okay, we have the best tree to be this. Now when we did that, right, as I said, if you see the time here, just to keep time of the various iterations that we are doing, and the time that is taken, right? So it will actually calculate the time for us, so you can see 1 minute 40 seconds over here, 19.8 seconds, right? And then 5.33 seconds over here. Now after iterating for basically it's 1,000 iterations, right? So after doing that, this is the best that we can have, right? This is the best that we can have, right? It's 0.83. That is 84%, right? That is 84%. That is after the 997 iteration, right? That's what we got, the best iteration. Okay, that's what we got. So the best iteration happened at 997th iteration, and the best test that we got is this, which is 84%. Okay, that's what we got. Now what happens is that as I said earlier on, Cutboost actually will help us handle these categorical variables. But all these are categorical variables that we have over here, right? The resource, the manager ID, the row 1, the row 2, the row department, the title, the family description, row family, and row code. All these are categorical variables. Now what happens is that we did not specify when we're doing this, right? We did not specify that they are categorical variables. So what it's going to do is that it's actually going to rank this, right? So if you take for managerial ID, for instance, it's going to say that managerial ID 85475 is actually greater than 1540, right? If you should just consider this, let me get rid of this. If you are to consider this and then that's as just quantities, right, then you can say that 85,000, right? You can say that 85,475 is obviously greater than 1,540, right? So if you consider the two, then you can actually say that 85,475 is actually greater than 1,540. but these are IDs, so we don't need to rank them. We don't need to say that one ID is greater than one ID. Okay, we cannot actually say that, right? So if you have, for instance, your row number, your college row number, you can also say that your row number is greater than the next person's row number. We don't rank that. Okay. So that's actually what the algorithm will actually do. That's the one of the mistakes that it will do. So what we're going to do is that we are going to actually specify that these are categorical variables, and therefore don't rank them. Okay, we're going to mention it to the Cutboost classifier that these are categorical variables, so don't rank it. All right, so that's what we are actually going to do down here. Okay, so over here, don't forget we have, if I should go a little bit up, don't forget we have this. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So if we start from 1, that is 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to specify that index 0, right? Index 0 to 8 is actually categorical features. Right, that's what we're actually going to specify here. So 0, right, starting from resource, right? So 0, 1, 2, right? So it's just going to make sure that we start from here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's what we are actually specifying here, that these rows, right? So if, for instance, these were not categorical, right, then we could have just specified 0, 1, 2, 3, right? Then we give it to the classifier to actually classify, and then learn from these as categorical, and then ignore these ones as categorical. But this, since in our case for this particular problem, all of these are actually categorical, we're actually going to specify that right from index 0, right? I mean, right from column 0 to column 8, right? They're all categorical, so consider them as such. All right, so that's what we are going to actually do. Moving on. Okay, so now you can see over here that I'm adding another one here, categorical features. That's what we just created. Okay, that's what we just created, categorical features over here. All right, let me undo. That's what we just created over here. That's why beginning I just created this param so that I can keep on manipulating it as I want. Okay, so and obviously you could have just put it inside. You could have just put all of them here and then still get to manipulate them, but it's easier to actually have them in this way. Okay, so that's what I'm doing. So the only thing that is changing here is just this one that I'm adding. Right, this is the only thing that is changing here. That's the same thing as train, while train, validation, right, and then true over here. So everything is just the same thing. Now, when we specify, right, if I show you up here, right, the one that we got earlier on, right, without specifying, remember that the best test was around this, right? This is the best test that we got. That is 0.84, right? 0.84. If you want to run it to the 2 decimal places, you can see that we have 0.84, right? That is the best test that we got. Now, after specifying the categorical columns, now see what we have over here, 0.89, right? So you can see there's a significant improvement in the best test that we got. There's a significant improvement that we got. And if you see the iteration, right, the best actually happened at 365 as compared to what we did earlier on here, right? 997. So keep on doing it several times before it even got at this one, right? But as we specify, we are able to get this only at 365. We're able to get it over there. Okay, we're able to just get it as compared to this. Okay, so we can also do cross validation over here, right? We can also do cross validation over here. Now over here, what is new over here? So the params are here, right? Just the same thing over here. Now we're adding this pool, right? This pool is nothing but just for data processing, right? Just for data processing. And so you can see we have our X, we have our Y, we have our categorical features, right? So all these are just the data that we have. So all the data that we have, we've put everything in this pool function over here. We are going to use that pool, right? and then we store it in the total train data. That is all the training data that we have, right? That's all the training data that we have over here. And that's what, so if you see this full here, you can see total train data. We have it over here. We have our params, right? Our params is here, and then the food count is seed, right? So because we're going to generate this randomly, we are saying that we are setting seed equals 1, so that we have same random variables over and over again when we shuffle. When we shuffle, it's several times, okay? And then stratify equals true. If you're not familiar with it, actually giving what it's actually doing here. So if true, the folds are actually made by preserving the percentage of samples for each class, okay? And then when we run that, right, when we run that, we can see the best test that we have is this, right? It's I mean you can either consider that or you consider this, right? So the best test that we have here is just 89, right? Almost 90, right? 89 as compared to this, right? As compared to this, this is a little bit above, right? This is a little bit above. We have 897, right? 897. But if you go down, if we use the cross validation, we have 892. Okay, so I mean this one is a little bit better, and the best iteration actually happened earlier, which is 365. If you see the best iteration here, it's around 995. Okay, that is a bit far. Now, which features are actually contributing for us to get these best test, right? Which features are important over here? In order to see which features are actually contributing the most, we use this get feature importance, right? So we are going to see which features are important. So I store everything that I'll extract into a variable called feature imp, right? So from cat model, remember that we store our if you go a little bit up here, when we did this, right? So when we created the model, we store it in what is called cat model. Okay, we store it in what is called cat model. Okay, we store it in what is called cat model. So that's what's actually I'm going to use, right? So in cat model, I'm going to see which features are important, right? So that's what I'm using. Get feature importance over here, right? Purify equals true will just make us have it in a beautiful format like this. Okay, so that's what. So over here, if you see the results that we have over here, right, we can see that our resource is actually contributing the most, followed by the managerial ID, right, followed by the department, right, the row department, and then the rep 2, right. If you see where rep 1 is, so rep 2 is actually contributing the most as compared to rep 1, right, and then the family description and the row title. So if you want to see maybe the first 5 features that are actually contributing the most, when we want to consider those features that we should actually base on when we want to grant access to an employee or deny access to an employee, these are features that are very important to be considered. So we can actually consider the first 5, maybe this, right, resource, manager ID, the row department, the row up to the row family, right, description. We can actually, if we want to consider the first 5, we can consider this. If we want to consider maybe the first 8 or the first 7, we can consider that. Okay, so you can actually use this get feature importance to actually know which features are important when you are dealing with this kind of data set, or when you're dealing with this employee data. All right, so that you get to actually know where you should actually concentrate the most if you want to take a decision as to whether to grant an employee access to a resource or deny an employee access to a resource. We can also visualize it, right? So this is just a visualization that I'm doing over here, right? So I'm going to use Seaborn, right? Seaborn is built on top of matplotlib. So in order to do that, I first import matplotlib, and then I use Seaborn, right? Seaborn as SNS, so then matplotlib dot pyplot as plt over here. Then I set the figure size. The figure size is nothing but just in the length and the width. So the width here is 6, right? And then the length, which is how long it will be on the horizontal axis, so it's actually going to be 12, right? So on the vertical it's going to be 6. Okay, that's what's actually happening over here. And then I'm using bar plot, right? I'm using I'm using bar plot over here, and then the X should be the importance, and then the Y should be feature ID. It's nothing but this that I'm having over here. Let me go a little bit up so that you can see. Yeah, you can see this one, right? So the importance, this importance that you can see here is nothing but this one that I'm picking, and then the feature ID is this one that I'm picking. Okay, so based on these two, I can, this one is nothing but just the title, and our data is just stored in that. Okay, so Cutboost feature importance is what you can see on the top over here. Okay, now if you visualize this one, you can actually see that we have resource, it's just the same thing that we're seeing on the table, right? Just that this one will actually make and graphically let you see which features are very important. All right, so we can see resource. If you see the bar of the resource, you can see how far it is, the second one, the third one, the fourth, and the fifth one over here. Okay, so you can see that these features are the most important when you want to consider whether to grant an employee access to a resource or not. All right, now we can actually make some predictions based on the model that we have built, right? Remember that we store our model in this. So this is all that they need. This is all that Amazon need. This is the model that they need, right? This is the only thing that is going to matter to them. So if they have a new data set, remember now we are using our test data here, right? Remember we store our test data in what is called the S-test, right? So in order for them to actually make predictions on this test, right? In this case, I'm going to check the probability, right? The probability that we will predict 0 or we will predict 1, right? That's the probability that we should deny an employee access to a resource, or the probability that we should grant an access to an employee of a resource. Okay, so that's what I'm going to use, predict underscore proba, right? We can also use just predict to see to predict either 1 or 0s, right? To either predict 1 or 0s. So if we do the predict underscore proba and then we make the prediction on our test data here, you can see that now the first one is this one, right, which is 1. Now the probability that we will grant the person's access is this, so it is 0.29, right? Or maybe 0.30 if you want to run it, right? Which is very low, right? Which is very low. But if you see the probability that we will grant the second one access is very high, right? The probability that we will grant the second one access is very high. If you see this one, right, it's very high, 0. Almost to 1, right? So some of them are having high, and then some of them are having low, right? So those having low will actually be 0. Those having high will actually predict 1, right? So that's the probability. That's using the predict underscore proba. Now, if we use this one, right? If we use dot predict, if we use our model to make prediction, don't forget we are making the prediction on the test data here. Okay. Now you can see we are predicting some ones. If zeros are there, we cannot actually see because it's broken over here. Okay. You cannot express everything. There's a huge data set, so we cannot display everything, but it's actually showing you that you're able to predict some ones and some zeros, which might be in between here. Okay, so that's all they need. They just need this thing. They just need this thing. So this has actually learned from the training data they provided for us. That's the historical data they provided for us. And this we have been able to use the Cutboost to learn from that training data, and then our learning is now actually stored in this cut model, right? So if a new data set comes in, right, we can actually make a prediction whether we should deny the person's access or grant the person's access. So if we have a data which contains the MGR ID, right, like the manager ID that they gave us, maybe the resource, right, the resource, the family description. So if we get data like that, we put everything together, right? We put everything together here, then we make a prediction. So if we predict 1, then Amazon is going to grant the person access. If we predict 0, then Amazon is going to deny the person access. This is the only thing they want us to do, and that's what we've done. Now, there's another problem with that. No, okay, now let me talk about this before I come to the problem. Now, cut model here, right? After using the model, if we check the score here, you can see that the score is very high, which is 95% or 96%, which is quite high, right? If we have 96% score, which is very high, right? Which is quite good. Okay. Now, what is happening here is that we should not be happy with this too much. Remember that earlier on I told you that if we check the ratio of the ones as against zeros, one was actually outweighing zero by way too much, right? If I should just do it over here, I think, yeah, I put it over here. Okay, I put it over here. I put it over here. So now you can see this one here, right? Let me use different, or maybe I should just clear this. Now you can see the ones that we have. I'm checking it from our original data, right? Original training data that they provided, right? The action column contains 0 and 1. So I'm just getting the zeros. How many zeros are there? How many ones are there? Now, if we count that, we can see that we have 30,872 and ones, and then we have only 1,897 ones, right? So it's possible that our algorithm is being biased here. It's only learning from these ones. So that's why if you see the prediction, right? If you spot the prediction over here, you can actually see that it's predicting mostly ones. Although we can't see what is inside there, but it's possible that they are all ones, right? It's possible that they are all ones and it's not predicting any zero, right? So it's possible that our algorithm only learned from this ones and did not learn from the zeros, because the zero is very small. It's actually overlooked it because of what we are facing now, right? That is data imbalance. All right, so that's why earlier on I told you that you should watch the credit card, the credit card fraud detection. We actually dealt with data imbalance in there, so you can check that video and then deal with this. Whether you do upsampling, right? You can do upsampling or you can do downsampling, right? So let me just, upsampling is nothing but, say we have this so we will be having, let's say we have this. Let's say we have this represents 30,000 data, right? I'm just using a bar to represent that. 7.2. Okay, then we have this, so this is actually going to be 1,897, right? So I'm just representing this bar. So this one, obviously 30,800, and it's actually going to be very, let me even increase it. It's going to be very tall, as against this one is going to be very short. So if we talk about upsampling, then what we are doing is that increase this one, right? Increase this data so that it will be of the same height with that, right? So there's a way to do that, right? There's a resample function that we can actually use to do that. Okay, and then if we talk about the downsampling, right? If we talk about the downsampling, then if I should represent the bar again, so we have the green being tall, and then we have the red, which was short, right? We have the red, which was short. And so if we talk about downsampling, then what we are saying is that you have to reduce this. So we're going to reduce this, right? You do this until they all become of the same height, right? Until they all become of the same height, right? Until they all become of the same height. So we're going to reduce this. So that becomes the downsampling. And then if we are increasing the small to become the same height as become the same as so this 1,897 should rather become 30,872, right? This one should increase to this amount. And if we are doing downsampling, then this one should reduce to this amount. If you're doing upsampling, this one should increase to this amount. If you're doing downsampling, this one should reduce to this amount. So as simple as that. All right, and we've done that in this project. So look into this project and know how to resample this, and then follow the same process as we've done again. All right, you can follow the same process as we just did. Okay, and then one more thing that we can actually do. one more thing that we can actually do is to actually, I've also given you a note here where you can take note of. All right, so I'll load this notebook on the platform so that you can have access to. So remember that we used Cutboost here, right? So if we're not doing Cutboost, then normally what we use in the previous videos, right? I mean, the previous projects, what we normally do is to use a library, right? So in this case, we could have just used logistic regression, right? Then remember that as I was saying, that Cutboost actually do the categorical variable, right? It handles that for us automatically. So we just need to specify. So if you remember, we specify that from 0, 1, 2, 3, all the way to 8, right? All these features are categorical, and then that's the only thing that we did, right? But if we are using algorithm like logistic regression, then we need to use the say one hot encoder to actually encode these categorical variables before we can move on to do to actually initialize this, maybe initialize to maybe any variable, maybe LR equals our logistic regression, right? Something like that. And then after that, we use our LR to actually fit our X train, right? We use it to fit our S train, and then our Y train, right? We use it to fit that. And then after it lengths, we actually go and do predictions, right? So after this becomes our model, so our model dot predict, right? We can either predict the probability, or we can either predicts just makes predictions on the test data like that, right? And then we can actually even check the score if we want, right? So this is actually going to be the process that normally we normally follow, right? And since we were using the Cutboost, we did not do this stuff, right? We did not actually use the one hot encoder to actually do this. Okay, sometimes if you use this, right, or like dummies for instance, you actually end up creating different columns, right? You end up creating different columns. So if you have a column which contains maybe 3 categories, maybe or maybe 2 categories, right? Maybe male, right, and then females, right? I mean male and female, just like that. If you do create maybe dummy variables here, right, then you're going to get maybe male underscore 0, right? It will have its own column, and then female underscore 0 will have its own column. Female underscore 1 will have its own column. So automatically you have added 2 columns, right? And if the categorical variables are more, then you are going to actually end up with, I mean, creating more columns, right? You end up creating more features, and you're going to end up with you're going to end up with case of dimension, right? Then you're going to end up with case of dimension, right? And you need to do dimension reduction using the PCA, right? So if you don't want to get to that extent, then I mean, Cutboost will actually help you in that case to get rid of that. Because if you don't actually do it that way too, then what your algorithm is going to do is going to do the same thing that Cutboost was doing earlier on, where if you encode this male to say 1 and you encode female to say 0, right, it's actually going to rank it and say that 1 is greater than 0, but under normal circumstances, male is not greater than female, or female is not greater than male, right? We don't actually want to make that assumption over here. But if you encode it to say male to be 1 and female to be 0, then that's what is going to happen. So what it's actually you're going to do is to create these dummy variables, right? You're going to create these dummy variables, and you're going to end up with so many columns, which will give you, I mean, throw you into the case of dimensionality problem. You have to go and then use the PCA. All right, so I mean, using the Cutboost will help us get rid of all these, right? Using the Cutboost will help us get rid of all these. So I hope you've learned a new thing. What I'll urge you to do is to use this logistic regression to actually build the same thing, and then you compare the results. And also don't forget the data imbalance, right? That's very important to actually deal with, right? So it's very, very important. So if you watch the credit card video, you're actually going to have an idea of how to do that, right? It's not anything. You're actually going to get that. So I hope you have learned new things from this video. See you in the next video. Have a nice day.